Ever find yourself wondering how those computer programs, you know the ones, manage to dig up the absolute best solution to a problem? Like seriously, think about it. Mapping out the most efficient delivery route, or even cracking some super complex code.
It's wild, right?
Totally. It's a whole world of research out there, and honestly, it's mind-blowing. So today, we're diving deep, really deep, into a paper that's all about a brand new approach, and get this, it's inspired by ants. Ants.
It's incredible how nature just seems to have these elegant solutions to problems that, let's be honest, we humans still kind of struggle with. This paper we're looking at, it zeroes in on a classic example, the traveling salesperson problem.
Ah, right, because even figuring out the shortest route, like if you're visiting a bunch of cities, that can quickly spiral into a computational nightmare for those traditional algorithms to handle.
Exactly. And you know where this is going, right? That's where our little ant buddies come in. You see, their whole foraging thing, especially how they use those pheromone trails to create like these super efficient paths to food, well, that's been a huge inspiration for a whole category of algorithms. We're talking ant colony optimization, ACO for short.
Okay, so instead of just randomly sifting through every single possible route, these ACO algorithms, they're taking a page straight out of nature's playbook.
Precisely. You know how ants lay down pheromones to guide their buddies to the good stuff, the food?
Yeah.
ACO basically replicates that whole process digitally. Imagine this: digital ants exploring tons of different paths and leaving behind this virtual pheromone trail. The more ants travel a specific route, the stronger that digital trail gets, and bam, it's like a big neon sign highlighting it as a potentially super efficient solution.
It's such an intuitive way to tackle a problem that seems so complex.
Right?
But the paper we're looking at, it doesn't just stop at mimicking how ants do their thing, does it?
You caught that, didn't you? You're right, it takes this whole concept a step further. It introduces something we call active inference. Think of it like giving these digital ants a little bit of foresight, the ability to not just blindly follow the trails, but to actually anticipate and adjust their paths in a smarter, more proactive way.
So they're not just reacting to whatever information's already out there. They're actually learning and adapting on the fly. It's like you're giving these algorithms a crash course in planning, a basic form of it at least. I got to be honest, I'm super curious to learn more about how this active inference thing actually works.
Okay, so picture this. Our digital ants can now analyze the whole structure of the problem, almost like they're mapping out the entire landscape before they even think about deciding on a route. And that, in essence, is what active inference allows them to do.
Whoa, that is fascinating.
Mhm.
So instead of just blindly following the strongest pheromone trail, they can actually consider multiple factors and make more strategic decisions.
Yeah.
This active inference, I have a feeling this could be a game changer for ACO.
It has the potential, that's for sure. It could be incredibly powerful. And this paper, it actually backs that up with some pretty compelling evidence. They put this new active inference ACO head to head with the traditional version. And the results, let's just say they were pretty revealing. But you know what? We'll dive into those details right after this.
This is what always gets me, the how. We've talked about what it is, these ant-inspired algorithms and this whole active inference thing. But how they measure how well this new approach works?
Good question. They set up a bunch of experiments, used the traveling salesperson problem as their kind of like their testing ground.
Okay.
They created all these different scenarios, some with just a handful of cities, others with, get this, hundreds, really wanted to see what these algorithms could handle, push them to the limit.
So it's like they built an obstacle course, but for digital ants.
Exactly. And they let both of them, the traditional ACO and the active inference one, loose on these like simulated road trips, tracked their performance, compared the results, the whole 9 yards.
Okay, and what they find? Did it live up to all the hype?
It did. The active inference ACO, it consistently did better than the traditional version. Found shorter routes, almost every single test, and here's the kicker, that difference, how much better it did, became even more obvious as the problems got more complex, more cities to juggle, that kind of thing.
Yeah.
It really highlights how much active inference helps these algorithms escape those dead ends, the ones traditional algorithms can get stuck in.
Makes sense, right? Like in those super complex situations, being able to think ahead, adjust on the fly,
Yeah.
it becomes even more important.
Exactly. And instead, it lets them find those really efficient solutions, the best of the best.
This is promising stuff, but there's got to be a trade-off somewhere, right? Like incorporating active inference, it's got to come with some kind of computational cost, doesn't it?
You're sharp, you know that. And you're right, there is. But it's pretty small, actually. The active inference ACO, it needed a bit more processing time compared to the traditional one, which makes sense when you think about it. It's got that extra layer of complexity, that whole predictive element baked in.
So a classic case of weighing the costs and the benefits.
Exactly. If you absolutely have to find the best possible solution, no matter what, even if it takes a little longer, well, the active inference ACO, it's worth it. But if speed is king, maybe you don't need the absolute best solution, just a good one, fast. Then the traditional ACO, it might be the way to go. Really depends on what you're doing, what matters most for that particular task.
Makes sense. Right tool for the job and all that.
Yeah.
But this active inference ACO feels like, I don't know, we're just starting to understand what it can really do.
Oh, absolutely. And that's what makes this research so cool. It opens up this whole new world for developing algorithms that are smarter, more adaptable. But there's a bigger picture here, even beyond the technical stuff. It changes how we think about solving problems.
Ooh, okay.
And that's what we'll get into right after this.
We've been, really digging into the nuts and bolts of this ant algorithm and this whole active inference idea. It's pretty mind-blowing.
It is.
But let's zoom out for a sec, look at the bigger picture. What does this research actually mean in the real world?
Oh, it's way bigger than just finding the best route on Google Maps, let me tell you that. Think
Yeah.
about it. Logistics. This research could completely change the game. Optimizing delivery routes, saving businesses time and money, tons of it.
And, we can't forget about AI. Everyone's talking about AI that learns and adapts in active inference. This feels like a huge step in that direction.
Huge, absolutely. Imagine self-driving cars, right? But not just reacting to what's around them, actually predicting, navigating like crazy traffic, but with this whole other level of, I don't know, foresight.
It's like they can see into the future of the road.
Exactly. We never even thought that was possible before.
It does feel like we're on the verge of like AI that can actually plan, think ahead, deal with problems before they even happen.
Exactly. And that's the thing about this research. It's like a sneak peek into that future. We're not just copying intelligence anymore. We're trying to understand how it actually works in nature, those fundamental principles.
Yeah.
And then we can use those to build better algorithms, way more powerful, adaptable, the whole package.
Like we're taking a page out of nature's book, right?
Yeah.
Evolution already solved all these problems. We just got to catch up.
Exactly. And the cool part is this goes way beyond ants, right? There are so many other systems in nature, each with their own way of doing things, solving problems. We can learn from all of them.
So this is, what, just the tip of the iceberg?
Yeah.
We could see algorithms inspired by, like, the human brain even?
Yeah.
Or the immune system.
Think about it. Algorithms based on, like you said, the brain, the immune system, even entire ecosystems.
Wow.
Imagine combining the best of all of them. Use active inference to kind of, I don't know, conduct them all, create this, like, symphony of problem solving.
That's an amazing thought. This whole deep dive has really opened my eyes. These bio-inspired algorithms, they have so much potential. And I'm starting to think, the more we learn from nature, the more we realize how much we don't know.
Isn't that the best part of science? Always more to discover, more questions to ask. That's what keeps it exciting.
Totally. And everyone listening, we hope this deep dive has sparked your curiosity, this whole world of algorithms, the amazing things we can learn from nature. It's incredible. And until next time, keep exploring, keep those questions coming, and never, ever underestimate a good idea, no matter where it comes from, no matter how small it seems.